I didn't have this on, so let me reiterate that the first quiz question this evening is page 375, problem number 5. And I'll read it. If animals are not conscious or do not feel pain, then they do not have any rights. Animals do not have any rights. Animals do not feel pain. Thus, animals are not conscious. So that's an argument.
That's a good ethical animal rights argument, too.
That doesn't make any sense. What?
Well, let me look at problem 4, because we're supposed to translate the arguments from English using logical operators, right? So the problem number 4, same page. Reads, if animals feel pain or learn from experience. So if they feel pain or learn from experience. Animals feel pain or learn from experience. Then animals are conscious. Then animals are conscious.
Oh, that's why this is so confusing. Because this is actually, is this a linguistic use of an inclusive or? Because like usually when we say or, it's this or that. But even in this sentence,
That is inclusive.
Wow, this is a sentence with a naturally inclusive or.
Mm-hmm.
That's why it's so confusing to me. That's weird.
Animals. So that's one premise, right? Animals do not feel pain, right? And remember, I used F for feel pain. So the next one would be not the case F, right? Animals do not learn from experience. Not the case L. Therefore, animals are conscious. So the question then is, now that I have this, right, is to figure out if this argument is valid or invalid, right? So let me line it all up here. So I have it all in a line. And I want to use a shortened truth table. I want to see if I can get C false. So if I can get C false, then this will be false. Right? But what I want to do is try to get all of the premises true. Right? So if I want to get this premise true, I need L to be false so that not L would be true. So L has to be false. I need F to be false so that not F would be true. So I need F to be false. So false or false would give me a false. And if false, then false is true. So I have a true premise, true premise, true premise, false conclusion. So this is invalid.
I think my brain melted again. I have no idea how you did that.
Okay, well, so here's my argument. I've got premise 1, premise 2, premise 3, and the conclusion.
Okay.
To find out if an argument is valid or invalid, what I want to do is check it for validity. That's what I'm doing.
Okay.
And the easiest way to do that is to figure out an opportunity or a case where the conclusion could be false.
All
And
the- is
even
that-
though the conclusion is false, see if I could have all true premises. Under what case could I have all true premises, right? So what I want to try to do is figure out what variation of truth values I could give this and be consistent. Remember, because this is actually a line. So I have FLC over here, right? And F is true and L is true. Oh wait, false. Sorry. F is false, L is false, and C is. Wait. Yeah. C is false. Not moving them over, right? Okay, so that's the line, right, for these three. Remember, I would have TTT, TTF, TFF, et cetera, right? So I'd have all these possibilities. Since there's three of them, 2 to the 3 would be 8, right? I should have 8 lines here. But one of those lines, in fact, it would be the bottom line, and the way I set up the table would be FFF, right? And if I had that situation with FFF and went across, I would end up with a false conclusion, but true premise, right? Because this whole thing is a premise. And remember, for a conditional statement, the only situation that would be false would be the one where the left is true and the right is false. But in this case, the left is false, the right is false, so the whole thing is true.
Even though it's false?
The statements are false.
So it's true that it's false.
The compound statement is true, even though the statements making it up are false.
Okay.
So, actually, we had our example, right? And the example was, we're literally we're going the opposite direction than we normally do here, because in this exercise, he's giving us what essentially is everyday speech, right? So I mean, some other examples. Problem 2, either you take a breathalyzer test or you get arrested for DUI. You did not take the breathalyzer test, therefore you get arrested for DUI.
Oh, that was like the first one we did. Modus ponens or tolens?
Either you take a breathalyzer test or you get arrested for DUI. So that's a disjunct, an or statement, right? You did not take the breathalyzer test, therefore you get arrested for DUI. So that is
okay.
actually disjunctive syllogism.
Okay.
Remember the way disjunctive syllogism works? You have P or Q, but not the case P, therefore Q.
Got it. Okay.
So that's actually, I just looking at that, I know that would be valid. And if I tried to use the truth table to show that would end up being in some case where Q would be false, but not P would be true, and P or Q would be true, that I won't be able to do it, because that would be a valid argument form. But so what we're doing, so 4 is the one that we've got up here. And let's go. If animals feel pain or learn from experience. So what I have here is animals feel pain. I would say that's true, right? So normally I would say that's true. And then this one is they learn from experience. I would say that's true. Then animals are conscious. And in fact, I would agree that animals are conscious, right? It's not the case that animals feel pain. Actually, I would say that that's false. And it's not the case that animals learn from experience. Well, I would say that that's actually false too, right? So I would say that animals are conscious, right? But the form of the argument is such that if I had a false or false, then false, this premise would be true. And then this one would be false, so true, because it's negated. And the same thing here, right? And yet, we could assume that the conclusion is also false in this case. So even though I like those statements, and I do agree that animals are conscious, the form of this argument is invalid. Remember that, it's nice to have true statements in your argument, and so he's being sly here in the book. He's saying all nice things that everybody wants to agree with, but then he's catching you because it's an invalid argument form. So he's going to catch you off guard, probably, in that particular case, right? So that's sly of him, right? Because you're going to feel like, hey, wait a minute, that's counterintuitive. Of course animals are conscious. How could, all these things are true. This is false, this is false. Well, but the test is the argument form valid or not? And that's what we're really checking, is the argument form valid? And the thing is, in a case where my three statements are false, I end up with true premises but a false conclusion. So this is an invalid argument form, regardless of whether you like the premises or not.
For the FLC, how did you know that they were all false?
I made it up. Because what I'm doing is creating a short form table, because I don't want to do the whole table. And he's saying, that's part of my exercise here, right? Use the short form truth table, right? And I'm aware that in order to demonstrate invalidity, what I've got to do is have a false conclusion. Wouldn't help if I said, well, what if this was true? Well, if it's true, then I can't show that it's invalid.
Can you, if you go through this, starting with it, the conclusion being false, but you work your way back and realize it's true, do you change it? So is that...
Well, I was ignoring whether the statements are true or false in reality.
Right.
Right, because what I'm trying to do is see if the argument form is valid or not. And so I'm fine with FLC. FLC doesn't mean anything to me. I'm not worried really about whether animals feel pain.
Right.
Right? That's whether the statements are true or not. But I'm just using this as an exercise example to analyze the shape of this argument, the form of this argument, right? So what I want is assume that the conclusion is false.
Every time?
Every time for invalidity, because what I want is to look at the line where the conclusion is false, but all the premises are true. So I'm deliberately trying to find the line, right? Let's do a different one. For example, number 7. Either you are right or you are wrong. You are not right, therefore you are wrong.
Is that another
So
disjunctive?
either you are right or you are wrong. You're not You are not right. Therefore, what? Either you are right or you are wrong. Either you are right or you are wrong. That's not right.
It's not right. It's you are wrong. That's
You are not right.
you are right.
Either you are right or you are wrong.
Isn't that
Not
PQ?
right.
That's PQ.
So you are wrong. That's
Not. You can be not right and still be wrong.
he's messing with my mind. So let's stick with the right or wrong. You are either right or you are wrong. You are not right, so therefore you are wrong.
Yes.
Is this disjunctive?
This is a disjunct.
Okay.
So if I'm looking at this going across, looking at it this way,
Okay.
right? And I want to see if it's this is a valid argument because it's just disjunctive syllogism. But say I wanted to see if I could figure out a line where it would be invalid. Well, so W has to be false because it's all by itself.
Mhm.
Right. It can get more complicated, of course, but we've got an easy one here. This is false, and that would mean this is false, right? But I want this to be true, because I want all my premises to be true, right? So I would have to make this one true for that to be true. But if R is true, then that's false. So guess what? I'm not going to be able to get a situation where the conclusion is false, but both premises are true. It's not going to work.
To be not right does not necessarily mean you are wrong.
That's right.
Right. That makes sense. That makes sense.
It does. It's counterintuitive normally, but
So is that one false or true?
this is a valid argument. What we're looking for is validity. The point of the
Okay.
right
So it's
is
valid. How did you get that it was valid then? I think I'm missing a piece.
well, I'm looking at this form and it's P or Q, but it's not P, therefore Q, and that is disjunctive syllogism, right? Right on the cover,
Right.
disjunctive syllogism, and so that's a valid argument form. And I recognized it as I was reading it, because I'm familiar with the form, right? Let's do another one. How about number 10? I'll just run this right across the top.
This doesn't sound logical.
Well, when you're making up a logic book, you're trying to be more funny than logical. So the examples are,
If I save $1 a day, I won't be rich. If I save $2 a day, I won't be rich. If I save $3, I won't be rich. So I will not save $1, $2, or $3. Therefore, I will not be rich.
It's always funny stuff.
if I save $1 a day, then I will not be rich in 10 years. So if I save $1 a day, then not rich in 10 years. If I save $2 a day, then not rich. Is that right? If I say 3, I don't want R, F, I'll make it F. 3.
Can the argument be either inductive or deductive and still have the same form?
Can the argument be inductive?
Or deductive and still have the same form? Like, is
It's
inductive
either
and
inductive
deductive?
or deductive.
Right, is that just a descriptor, like,
If
you
it's
know,
a
like
valid
sound?
argument, then it's going to be deductive. If it's an invalid argument, it's inductive.
Oh,
Remember, invalid arguments are inductive arguments. Inductive reasoning is invalid,
always.
always.
Gotcha.
Deductive arguments
Or valid.
are valid. Although, you get into arguments over attempted deductive arguments that are not deductive, that you tried. So some people want to say that that was a deductive argument, it's just invalid. But others will say, well, but since it was invalid, it's not deductive.
But you can approximate an inductive argument with a deductive argument.
I would say no.
No.
It's either one or the other. It's pretty clear, it seems. But yeah, this feels like he's enumerating, which is inductive.
Right, that's why I asked the question.
Okay, so where did I? Isn't this going to get more interesting or not? I will not save $1 a day. Okay, so not D. I will not save 3, not T. Or is that F? I forget. That was F. This is a boring argument, isn't it?
Because it's wrong.
Well, that's-
Sorry, invalid.
So,
Is it
there should be-
invalid?
Sounds
I
invalid.
should have not 2 and not 3. Therefore, not rich. Well, if I want to make this turn out to be an invalid argument, I want this to be false over here, which would mean that R has to be true. So R has to be true, which would make that false. Has to be true, false. So far I've got 1, right? I want this to be true, because I want all my premises to be true. So in order to get this true, I need this to be false. So this has to be false. I want this one to be false, so that it's true. And I want this one to be false, so that it's true. So that's all of them. So I've got this, the conclusion is false. I have true, true, true. And now let's see how this one works out. If false, then false, which is true. If false, then false is true. If false, then false is true. So all my premises are true, but my conclusion is false. So this is invalid. And boring. Almost put me to sleep.
Am I the only person not getting this?
I don't get it either.
No,
I don't get it.
Okay.
I'm getting the impression that nobody's getting this.
I mean, I feel like my brain is Swiss cheese right now, and I have 6 kids. So that's really saying
Swiss
something.
cheese is really good cheese, though.
But it's full of holes. Like my brain.
I've always wondered about that. Where do they get the holes from?
When it cooks, there's gases. So it just comes out. Sort of like how bread has air pockets. It's the same thing.
So I have holes in me?
If you have Alzheimer's, you have holes in your brain.
Great, now I've got Alzheimer's.
I'll check with you next week and see if you remember saying that.
I won't.
That is so dark.
Okay, so let me see if I could explain what we're doing, because that's probably the problem here. So we could use truth tables in order to determine whether an argument is valid or invalid.
Okay.
Keep in mind, since we're only talking about validity, talking about the form of the argument, we're not really concerned, we're not being scientists right now and checking whether or not our data is true or false. We're not checking whether or not the conclusions of our arguments are really true or false. We're checking the form of the argument. So on these statements, on these arguments on this exercise, they're just totally made up, and they're not concerned about whether or not the statements are true or false. Notice they don't say, hey, these are true, figure out whether the argument conclusion is true or not. They're not trying to do that. So that's all just a smoke screen.
The content doesn't matter.
The real issue is the argument form valid or not? And so I want you to transform these into symbols.
Okay.
So that's good practice for transforming it into symbols, right? And then looking at how the truth values would line up if you were trying to figure out this particular line. I mean, this is a pretty long argument. If D, then not R. If T, then not R. If F, then not R. Not the case D, not the case T, not the case F. Therefore, not the case R.
Okay.
So the whole point of it is, how can I fill all this in and see if I can get a false conclusion, but all my premises are true? And this one particular line where T is false, F is false, but R is true. Did I do D? I didn't put D up here. But D was also F, right? So D, T, F are all false, but R is true. Which is, that's easy, because the conclusion is not R. So if I just make R true, then not R is false. And it just easily worked out that every single premise turned out to be true. So this is a really easy argument to see that it's invalid.
I'm with you, and like in taking the words and doing the line across.
Mm-hmm.
And then I get the F, because I understand we're trying to prove that it's valid or invalid, so we're gonna naturally assume it's an F. Everything
Well, no,
going that
actually,
way,
in saying that, remember that the reason the argument is invalid is not because the conclusion is false.
right, it's just an invalid form.
Right, okay.
But we're always gonna start with an F and then work that way.
Right.
And once we work that way, it doesn't make sense. I'm not getting how we're plugging those in.
Right.
I don't get that.
That's the exercise where we're practicing what the logical operators mean. And that's based on my introducing what the logical operators meant with the truth table, right? So in my head, I have all those other truth tables that explain what the horseshoe means, what happens when I have a negation in front of it. That's easy, right? You know, if R is true, not R is false, right?
But how do you, oh, okay.
And
So
what
where
I'm
is
trying
that
to do
in
is
the
get
book?
all of the premises true.
Because that's a formula, right? I'm hearing that's just the formula, like
right.
the syllogisms.
Right.
So where is that formula
when
in
you
the book?
see if P then Q,
Yeah.
so what does this mean? It means when P and Q are both true, the whole thing is true. When P is true but Q is false, the whole thing is false. When P is false and Q is true, the whole thing is true. And when both are false, the whole thing is true, right? So this pattern,
Two falses make a true? And a false and a true make a true?
if the moon is made out of green cheese, then President Trump is female. That's a true statement.
If the moon is made out of cheese, then
Because the moon isn't made out of green cheese, and of course President Trump is not female as far as I know. The odd thing is, since I know that the moon is not made out of green cheese, even if President Trump is a female, this is still a true statement.
Okay.
Because if F, then if false, then false.
Oh.
false, then true.
Remember when my son goes out to take the trash out, right? If he, if you take out the trash, I'll give you a quarter. So he takes out the trash, I give him a quarter. He takes out the trash, I didn't give him a quarter, I lied to him. That's when the statement is false, right? If he doesn't take out the trash, but I still give him a quarter, he just laughs at me, but he's not gonna be mad at me. I didn't lie to him, right? But if he doesn't take out the trash and I don't give him a quarter, he's not going to say I lied to him. So a conditional statement is true even if both of the statements that make it up are false. So that throws you for a loop, doesn't it?
So the conditional statement itself is a meta statement about its premises? Is that am I using language correctly is what I'm trying to ask.
That's kind of interesting. I wouldn't say that a conditional statement is an argument.
Okay.
So I wouldn't refer to its two. So this is the antecedent, and this is the consequent.
And their value.
And what we're puzzled about is the logical connector. How does that logical connector?
She killed something up.
There was a spider, sorry.
That was George.
I killed his brother Bill a little bit ago.
George.
Oops.
Never going to bring them back. That's just because they're dead. Oh, well. Those are my favorite spiders. No, I'm kidding. I didn't bring any spiders that I know of for class.
Ah.
They're just little red ones that I feel like.
Oh, the little red ones?
Yeah. I
Are
had
those
some on
mites?
Are they spiders?
What are they?
Mites? Are they little red mites?
Yeah, they're mites.
Yeah.
They come-
Mites.
Yeah, they come out when there's heat.
Yeah.
They're not spiders.
No, they're.
No, they come from your nose when you're not looking.
Where do red mites come from? I don't know. That's
I'm
great.
just kidding.
Do they bite though?
Yeah.
No.
Yes? I wouldn't know. No, yes. Well, one of those two is correct.
They do not bite.
They do not bite. Okay.
Their mouths are way too small to bite.
Is there like a pest problem then or something? Should I be concerned?
No.
Yeah, because the university doesn't have money to fix it.
Oh.
Oh
All right. Well, let's do one more of these, and then we'll move on to something difficult.
So the table thing that you're talking about, where is that in here? I feel like I'm.
Okay,
missing it.
well, actually, we're looking at tables on every page. But if you, what table did you mean? The one about P and Q?
Is it the truth functions? Is that what we're looking at when you're
Yes.
plugging in the F and T's?
Yes.
So we
In
need
this
to-
section, we're using the symbol system in order to study how we think, and we're not getting away from the idea that in everyday speech we use compound statements.
Oh, for the love of God.
The love of who?
God.
You found
It's-
it. She's found it.
They change. They're all different. That would have been helpful to know. I thought they were all the same.
Ah, well, each logical operator has a different table,
Now I know that.
and that's why it's different. Yeah.
It's not different
Okay.
because of the. It's different because of the operation that produces the table.
So there's a difference for when I say and or if, then, or if and only if, or not. Those are each different.
So can I try to see if so just as a example, for conditional, I think it is, because it's got the horseshoe.
Right.
So T then not R. So in the book it says T, T, T. But here you've got F, F. I don't know how the hell you got that.
Okay, so you're looking at what's on the left and what's on the right,
Wait.
and in the case where both are false, if
Then it's
F
true.
then F, then it's true.
And so,
So-
not R would be,
If
How is-
false, then false. The whole statement is true. Not R is false. R is true. So what I'm looking at here is,
so,
this is a
Oh.
compound right here, right?
and so it's
So
true.
R is true, but not R. So I wrote the true under R,
As like a marker
right?
to kind of guide it. Okay,
Mhm.
so if it's true, but it's equal to
But
D,
it's
then
not,
it's false.
so it's false. So if false, then false,
Okay,
which is the bottom line there.
which
gives
is
me
true. So you just have to find the right formula for the right.
So,
Whatever
and
this is called.
I know that since 1970, I've known that.
And you can have all
And
of these different. This
It's
is
too long. It's too long.
the Soviet Union was still an enemy then.
Now they're a different kind of enemy.
They're not an enemy now.
Putin?
In fact,
Okay.
when I was in Berlin, we were allies. The Russians were our allies. They were our allies in World War II.
Oh, well, of course, yeah. Because Nazis are bad. Something people seem to have forgotten.
Nazis, yes, are
Nazis
bad.
are bad.
Right, I get the negation because that makes sense, and conjunction and disjunction.
Let's do another one.
And conditional, but have we talked about biconditional? Am I insane? Did we already cover that?
Biconditionals are P if and only if Q.
If
Another
and
way
only.
of saying this is IFF,
IFF.
if and only if. And if they're both true, it's true. If one is true and one is false, it's false. If one is false and the other one's true, it's false. And if they're both false, it's true. So that's what the biconditional means. So we will go to the beach if and only if the car turns on. So we go out and car turns on, we go to the beach. I didn't lie. That was truthful. If we go out to the car, go to turn it on, and it doesn't turn on, we don't go to the beach. I didn't lie, because we didn't go to the beach. If I go out to the car and turn it on, and we drive to the store and then come home, I lied when I said we will go to the beach if and only if the car starts.
So this is if then, and that's if and only if.
Right.
True, false, true, true. Okay, so the difference is.
It's actually, there's a relationship, because if you look in the book and you go if P then Q, and if Q then P, that's equivalent to this. Which is cool, because you could use equivalence to reflect the equivalence.
Oh,
It's kind of a meta-meta, I suppose.
If P then Q, and Q then
And
P,
P.
then P, if and only if Q?
If and
Did I read that right?
If you look at the cover, where did it go? Material equivalence, also abbreviated equiv. It's the bottom right above tautology. Notice on the left side you have P if and only if Q. In this book, instead of using an equivalence sign, he uses 4 dots. That's a cheat. That's really equivalence.
I thought 4 dots is there. No, 3 dots is there for. I'm sorry.
Well, this is 4 dots.
What's 4 dots then?
A cheat for an equivalence sign.
Oh no, he's got the 3 lines. It's just in material equivalence.
You see the first line says that's equivalent to if P then Q and if Q then P, which is what I have there. It's also, by the way, and this is one of the odd ones where you could actually go, you have to go through the equivalence to transform it, but you can also go P and Q, or not the case P and not the case Q. That's also equivalent to P if and only if Q. So if you need to, you could swap them
Okay.
that way. But let's do one more of these problems. Eddie can vote. This is page 376. It's just like learning Spanish. The more you do it, the easier it comes. No hablo español, but I believe that that's true. So, 17, page 376. And what we have is Eddie can vote if and only if he is registered. So E, if and only if R. Eddie can vote. Oh, wait. Thus, Eddie is registered.
I feel like this is not a valid argument. Maybe I'm wrong.
Yes.
It's not a valid argument?
No, it is a valid argument. You're
Is
wrong.
a valid argument?
Yeah, well, the conclusion is he's registered, right? Well, let me see if I can make that false. I can, right? So R is false. Let's put over here, R is false. So I want E to be true. So E is true. And I want this to be true. But remember
Wait,
that
why
what
did you want E
this,
to be true? Sorry.
because this is a premise,
Right.
and this is a premise, and this is the
The
conclusion. To show that this is an invalid argument,
The premises must not be the same as the conclusion.
the conclusion, you have to be in a situation where the conclusion is false, but all the premises are true.
Gotcha. Okay.
It's not gonna work in this one because this is a valid argument, right? Because these are equivalent. And this has to be true. So then this has to be true, which means it can't be false. So it's gonna be, so it's
Oh,
going
okay,
to
So
be
if I were to
valid.
write
page-
out the truth table, I
Right,
would
so
never-
if we look at the truth table over here, right, which is essentially right here,
True.
right? And R has to be true, right? That's, in this case, it would be the Q, right? Then if R has to be true, then the P, the E has to be true, right? And that's what that actually means, right?
But there is one where the Q is true and the P is false.
Right, but it's false in that case. For this to be true, that's what we have to do when we're doing this.
Okay, I'm sorry, I was looking at the wrong column.
What we need is true. And so the only case where the whole statement E, if and only if R, is true, would be where both the E and the R have the same truth value. So I can make this true and have E true, but then R has to be true, but I want it to be false. So this is a valid argument.
I got how we got E as T, but how did E and R get T again?
So if E is T, then I have to make R T. Otherwise, this will be false. But I want it to be true, which means that this can't be false, it has to be true. Which means I can't, this isn't an invalid argument, I can't show that it is.